Hello, and thank you for joining us at the NECA 2020 Virtual Safety Summit, presented by Westex. Our next breakout session is significant changes to the 2021 NFPA 70E standard for electrical safety in the workplace. This session features Jim Dollard, retired safety director at IBEW Local 98, and Palmer Hickman, the director of codes and curriculum for the Electrical Training Alliance. NFPA 70E is revised on a 3-year cycle, and each edition brings significant changes. Mr. Dollard and Mr. Hickman will identify proposed changes from the previous edition and how it impacts employers and employees. Thank you, and we hope you enjoyed this session.
Hello, everybody, and welcome to our presentation. And at this point, I will open our PowerPoint. And today's presentation is titled 2021 Significant Changes, but we added much more, and we want to start by talking about objectives. What is the objective of NFPA 70E? More and more we see confusion with contractors and journeyman wiremen. They believe that this document is their guide to working energized, and nothing could be further from the truth. Palmer?
Great point, Jim. So yeah, we saw a presentation yesterday afternoon that really did get into once you have met the threshold for working energized, how to work energized. But we've, as a committee, both Jim and I represent the industry on the 70 committee, and we've even reorganized the standard in a more logical way to make it clear that creating an electrically safe work condition should be our first priority.
Yeah, and that reorganization that Palmer just mentioned, that's really the theme of the 2021 edition of NFPA 70E. We didn't see any earth-shattering changes, anything really major. There's a lot of changes, don't get me wrong, but we didn't see anything that is going to cause you to lose sleep at night. But we wanted to start this program off by emphasizing that the goal of NFPA 70E is to eliminate the hazard. And when we get into to doing just that, and we get into what contractors are required to do in their risk assessment procedure and the hierarchy of risk control methods, we're going to show you some changes that elaborate on the fact that the creation of an electrically safe work condition is a state, and that state is considered as elimination for the period of time that it is maintained. So we'll take a look at some of our objectives today, and we mixed it up a little bit. We're going to talk a little bit, start with NECA's electrically safe work condition campaign, and Palmer will elaborate on that. We will also focus on compliance with OSHA regulations. NFPA 70E is a consensus standard. The only entity that we know of that formally adopts NFPA 70E is the Department of Energy, but OSHA is the shall, 70E shows you how. So we'll focus on compliance. We will review several significant changes in NFPA 70E in the 2021 edition, and we will verbally bring up many more as we go through this presentation today. We will focus on risk assessments. NECA has a new guide out for shock and arc flash risk assessments. It's a very useful tool for all employers. It's a tool for the qualified person. It is not a substitute for training. And what that guide does is get you into the process of performing risk assessments. It lays it out in a very practical, easy to read, easy to apply format. And those risk assessments are both shock and arc flash risk assessments. We will also discuss requirements for justified energized electrical work. And in many cases, they're misunderstood and misapplied. So Palmer and I will dig deep into the justification requirements in NFPA 70E, as well as the fact that they have been reorganized, relocated. Everybody knows to go to 130.2. For those, they've been moved up front into the beginning of Article 110. And we will talk about the documentation that is required when performing shock and arc flash risk assessments. There is, and we'll talk about that just a little bit right now. There is a mindset that the only time I need to document is when there's a need for an energized electrical work permit. And Palmer, do you want to elaborate on that a little bit?
Well, certainly one of the biggest things is, as Jim just mentioned, justified energized work by qualified person. So when are you considered to be a qualified person? Well, we'll speak to what 70E says. You're only considered a qualified person if you have documentation when you demonstrate a proficiency on the task. So there's a big documentation piece besides the shock and arc flash risk assessment. So, you know, some people might say everybody with a ticket in their pocket's a qualified person, and we're going to see that that's not true by definition, and it's not true by the requirements that the documentation has to be on file for the employer for the duration of the employee's employment when they demonstrate a proficiency in the task.
Absolutely. And something else that is misunderstood fairly widely in the industry is the documentation of a shock and an arc flash risk assessment. NFPA 70E tells you in 130.4 that you must document all shock risk assessments. In 130.5, we tell you that you must document all arc flash risk assessments. And we're all very familiar with the requirements for energized electrical work permits. And when we fill out an energized electrical work permit, it's going to require that we document the shock risk assessment and the arc flash risk assessment on that form. But when we do tasks such as troubleshooting, using a test instrument, a voltage tester, we have to do a shock risk assessment. We have to do an arc flash risk assessment, and we have to document those. We're not documenting them today. We have to do that. We have to get that done because NFPA 70E also requires you to audit all of your field work. And that's the only way that you're going to be able to
So
do
Jim, you brought up a great point there. So we know there's exceptions to the permit, and that's usually where people think, oh, well, then I don't have to document it. And quite frankly, you do still have to document it. And so even if the permit doesn't apply, a lot of people still use the permit. They just don't require the signature for authorizing energized work.
Yeah, and that's one of the things that you'll see in the NECA guide to shock and arc flash risk assessment. So we're going to start off talking a little bit about justification, qualified persons, risk assessments, the hierarchy of risk control. I'm just going to throw it all on the screen and we're going to get into it here, which is going to get us into an electrically safe work condition. But the justification, and we'll put those thresholds up on the next slide or the one
Slides.
following that, it has to be in place. The justification has to be there. It's 2 slides back. We have to, before we can do energized work, it has to be justified, and qualified persons are required. And we're going to dig deep into what makes a qualified person a qualified person. And, you know, do those definitions differ, Palmer, between 70E and OSHA?
They do. And they're at their core, they're essentially the same, but they are different. There's subtle differences. OSHA doesn't update as frequently as NFPA 70E.
Absolutely. And risk assessments. We do risk assessments all the time. We'll get into the definition of risk assessment, and we'll talk about shock risk assessments and arc flash risk assessments. But it's imperative that when we train, we document proficiency of those qualified persons, and that proficiency has to be the capability of accurately performing these risk assessments. And the hierarchy of risk control, method number 1 is elimination. And that is the goal of the standard. And we've got zero energy in there because that's the term that is used in NECA's standing safety policy. And NECA's standing safety policy says that the best practice is to always remove the hazards. The best practice is to create an electrically safe work condition, and we're going to dig deeper into those. But this is just a little snippet from the NECA standing policy on safety, and that is that NECA believes that to achieve zero injuries in the workplace, members must strive for zero energy work environments as the normal and best practice whenever achievable. Why do you think they added those words at the end, Palmer, whenever achievable?
Well, there's cases where we have to work energized and it is justified. So there would not be a case where there's zero energy. So for example, troubleshooting, verifying absence of voltage during voltage testing, it's energized work that we have to do, that it is justified energized work would be an example.
And that's a key point that Palmer just brought up. In many cases, we've got people in the room and we say, hey, who does any energized work at all? And nobody raises their hand. They say, no, we always create an electrically safe work condition. As Palmer pointed out, the action to verify de-energization is considered energized work by both NFPA 70E and by OSHA.
Yeah, and this policy is a great policy. I know General Ron brought that up yesterday afternoon in the general session to kick us off, started the day off right with NECA's standing policy on safety.
Yeah, there's, when we get to a zero injury environment, we're going to be more competitive in the market. We're not literally putting ourselves out of business. Today, OSHA serious fines are over $13,000. A serious fine is about $13,700. If you get and once you get a serious citation and it's held up, the fine, forget that money, that's nothing. What happens at that point? Let's say, for example, you had somebody come in contact with energized parts and they fall and they hit the ground. I'm explaining a scenario that occurred several years ago in Philadelphia. The general contractor sees it happen. They call 911. Well, when that happens, EMS contacts OSHA, and now that contractor gets a serious fine. He gets fined for $1926.95 for PPE, $416 for exposure, and maybe $1926.21 for training. Now you open a 5-year window in which if you get a similar citation, it'll be repeat or willful. And now that's up around $136,000, but that doesn't matter because you'll be out of business at that point. You won't be able to get insurance and you won't be able to get on bid lists.
That's even serious money to you, Jim.
Yeah, it is. It is.
Jim, click through all the slides. I think the first bullet point will come up last, and that sort of sets the stage.
Okay. Yeah,
okay, so this is the campaign that NECA, IBW, and ETA have been promoting for months, started back in Electrical Safety Month. So at a high level, what must be considered to determine if performing energized work is justified and in compliance with OSHA and 70E? So two things, and I think maybe these could be reversed, but whatever, but these are the two of the key points. Only qualified persons can perform energized work. And probably the first step is the work must be justified. So at the bottom 4 bullet points, you'll see these are the 4 reasons that we can work energized. And as Jim mentioned, this is what we used to get probably 20 years or more ago when we first started talking about 70 and OSHA and when you're allowed to work energized. We'd ask the class, when do you work energized? And they'd say, oh, we never work energized. Well, we didn't know if they were just telling us what we wanted to hear, or if that was really the truth. But we would say, well, we're really sorry to hear that, because that means you don't do lockout tagout. So if you don't ever do energized work, that means you don't do lockout tagout. because it's still considered energized until you've verified it's de-energized. And we'll cover this a little bit later. Matter of fact, OSHA, and this came up in yesterday's presentation yesterday afternoon that Zachary did, OSHA considers if it's de-energized, it's considered energized. And it kind of makes your head spin a little bit, but de-energizing is one step in lockout tagout. De-energizing is one step in achieving electrically safe work conditions. So we think we know what everyone means when we say only work de-energized, but de-energized is just one step. So de-energized is not the same as locked out and tagged out. De-energized is not the same as an electrically safe work condition. So you have to be justified. So here are the 4 reasons in feasibility. So troubleshooting would be an example of that. Additional hazards, you could think of a few things there. That's probably the one our customers push us the hardest on and is probably not really an additional hazard, but something to think about there. So if you're going to shut down the air traffic control system at 5 o'clock on Friday, that would probably be increased hazard or additional risk. So what we really need to do is think about, can't you shut it down at 2 o'clock on, in the middle of the morning, middle of the evening, that things like that. Equipment less than 50 volts, there is some clarification there. It doesn't mean everything less than 50 volts, but there's a threshold, and normal operating conditions. So we've clarified this a little bit better for the 2021 edition. So 2 key takeaways here. The work has to be justified. So we shouldn't be doing any energized work that doesn't meet one of these 3 thresholds, and the person has to be qualified. And we talked about this a little earlier. We're going to talk about this several times as we go through. According to 70E, you're only a qualified person if you have a lot of things, but one is documentation of your proficiency on file for the duration of your employment. So you might have 50, 100 electrical workers on the job. How many of them are qualified? How many do you have documentation of their proficiency on file? Thanks, Jim.
Yeah, thanks, Palmer. And just a quick question, Palmer. I still see tool lists for, I can remember when I got my letter, when I got into the apprenticeship for Local 98, I was so excited. I just went crazy with excitement. And I knew when I opened that letter that I had been accepted, because the first thing I saw was a tool list. And when I saw a tool list, I thought, oh my God, I got accepted into IBEW Local 98. Now, on that tool list and on many tool lists today for local unions throughout the United States of America, apprentices are required to purchase and have a solenoid type voltage tester, which is known in 70E as a test instrument. So Palmer, I'm a brand new apprentice and I come on the job with that test instrument, that solenoid type voltage tester. Can I use it?
Well, not if you're not a qualified person.
And that's one of the key takeaways. If an individual, you could have a journeyman wireman with 30 years experience on the job. The only way that the employer is going to be able to make a determination that wireman is qualified to perform justified energized work is if they're trained in accordance with NFPA 70E. They follow all of those rules. They're trained on the test instrument that they're going to use, and they can do a shock and arc flash risk assessment. Palmer spoke briefly about some of the thresholds there in feasibility. That's where we see most of our justified energized work, because it's task driven, which means I cannot perform my task unless I do it energized. So the best example there would be troubleshooting or measuring voltage, because we have some type of a problem. If I shut it off, I'm not going to be able to perform my task. Additional hazards or increased risk, as Palmer pointed out, is where, we can't de-energize this equipment because it creates a greater hazard. Maybe if I de-energize this panel board, I shut down purge fans and I'm going to allow a combustible atmosphere to develop somewhere else. That's an additional hazard. But for you, the contractor, you have to understand that when you use that justification threshold, additional hazards or increased risk, it's a double-edged sword, okay? Because now the equipment that the owner is telling you they can't do without for 20 minutes might be out for 2 days or 2 weeks if something goes wrong. So you need to document that. Equipment less than 50 volts, normal operating condition was a really good change that came in a couple of cycles back into NFPA 70E. So, there's a number of things that we have to look at. We have to make sure that, there's no defects in the equipment. There's no evidence of impending failure. All of the screws and bolts are in. And there's another piece in there. You have to make a determination that the equipment is properly maintained. So Palmer, you and I go into a building that, it's 20 years old, still seems to be in decent shape. And there's nobody in that building that knows anything about their distribution system. Can we make a determination that any of that has been properly maintained?
Absolutely not. That is probably one of the most common occurrences. So probably a common theme we've all seen in edition after edition of 70E is the importance of maintenance. And quite frankly, that's one thing that I wish we could do better as a committee to give better guidance to the industry, but we really can't. So it says, consider the condition of maintenance, take into account the condition of maintenance. So if you thought it was going to clear in 2 cycles, but it hasn't been maintained, and usually the biggest culprit, if you had to pick one, is the lubrication dries out and it's no longer a lubricant. It becomes stiff and sticky. So you thought it was going to clear in 2 cycles and it cleared in 30. So you thought you were going to be okay wearing 8 calories of protection and you needed an arc flash suit of 40 or more. And you thought the arc flash boundary was going to be, let's say, 2 feet. And because of this delayed opening time of this, because of lack of maintenance, now the arc flash boundary is 10 feet. And so people that you thought were outside the arc flash boundary wearing flammable clothes are involved in the arc flash event. So maintenance is huge, and it's a big problem. I think one help, NFPA 70B is now a recommended practice, means you should do this, you should do that. They're changing it to a standard, just like NFPA 70E is, and it's going to be shalls. So we're going to see a lot more guidance as far as, not guidance, but enforceable language for those that adopt 70B, Bravo, that'll tell them how often and how to maintain equipment.
Yeah, and that scenario that you were describing, Palmer, we see that regularly with low voltage power circuit breakers. And Palmer mentioned 70B, and 70B is going to tell you that they need to be maintained every 3 years. Manufacturers will tell you every 5 years. So somewhere in that window, they need to be maintained. But you've got a journeyman wireman on a job that has to open one that hasn't been maintained in 20 years. Well, we don't know what's going to happen. It's obviously not maintained. And as Palmer pointed out, the incident energy is directly proportional to the time. So if you get 300% of the clearing time, if you go from 6 cycles to 18 cycles, you've got 300% of your energy. All right. And we're getting back into, and Palmer, I mentioned this to you earlier. I asked you about the definitions of qualified person in 70E and then in the OSHA standards. Can you discuss that?
Yeah, so there's 2 definitions that we primarily deal with, and I guess 3 if you look in the construction standard, Part 1926, Part 1910, the general industry standard, and NFPA 70E. So at their core, they're certainly similar. So 70E tells us one who has demonstrated, so that's where we see demonstration, and you'll see later in the standard in the training requirements that it has to be documented. So one has demonstrated skills and knowledge related to the construction and operation of the electrical equipment and installations, and has received safety training to identify their hazards and reduce the associated risk. So that's a really, really nice definition. And then from OSHA, one of the definitions, OSHA, one who has received training in and has demonstrated skills and knowledge in the construction and operation of the equipment and the hazards involved. So the hazards are shock, arc flash, thermal burn, and arc blast. So Jim has mentioned a couple different risk assessments that we're required to do. And I think it's important to recognize there's another hazard, at least one more, arc blast, that is a recognized hazard, but there is no risk assessment for that. Basically, 70 standard will tell you a couple times, the goal is reduce and survivable injury. So keep that in mind, safety professionals. Every time that we say, yes, we can do this energized, the goal of 70E is reduced and survivable injury with no protection against arc blast.
Yeah, we, at the committee level, we have a difficult time. We don't want to start putting you in Kevlar. A key piece in that definition in 70E is demonstrated skills and knowledge related to the construction and operation of electrical equipment. So if Palmer and I were working for you today, and you were going to instruct us to do some work in a piece of equipment that was going to start 3 generators, synchronize their output, tie them to common bus, and supply power to the installation, I wouldn't be a qualified person because I would not be familiar with that piece of equipment. And it's something for our frontline foremen to be all over. They have to make sure that everyone that they're putting into a piece of equipment understands the construction and operation of that equipment. And we have seen many incidents occur, and that was a big part of it because they didn't understand the equipment.
But we could get there with training.
That's right. And that's the key. We can always get there with training. So who determines qualification? It's
The employer.
And who's the employer on the job? In the eyes of OSHA, that's your frontline foreman. He's going to make that determination. Palmer?
Yeah, so you're going to hear this common theme several times throughout, and because we think it's important. So if you're looking to move the needle in your safety program, you think, okay, how can I make my safety program better? How can I do better as a safety professional? I think this is one place. We need to make sure we don't assume everyone is qualified. That's step number 1. That's the first thing we have to come to a realization. Not everyone is qualified. Matter of fact, I think we need to consider everyone unqualified until they've demonstrated proficiency and we have documentation that they are qualified. So that really is what we're saying here. Documented by the employer when the proficiency is demonstrated right out of 70E.
And then proficiency, what is that? The documentation piece can be very difficult. And we have seen contractors get extremely proactive and say, you know what, I'm going to set up a panel board, a switchboard, an industrial control panel, and they're going to demonstrate proficiency on those 3 pieces of equipment. And that's great, but that doesn't demonstrate proficiency on everything. And we need to understand that. It's key. It is key that all qualified persons have the ability, and they demonstrate the ability to do an accurate shock risk assessment and an accurate arc flash risk assessment. They have to get that done. That is a key piece. And in 2018, we changed things up a little bit. We didn't send you right to the arc flash PPE tables. We didn't send you right to PPE if you've got an incident energy analysis. Now we say if additional protective measures are required, now you go to the hierarchy of risk control. Palmer?
Yeah, so we'll start at the most common justified energized work as an example. We're going to cover this a little bit later as well, but voltage testing, troubleshooting, or I would say, hopefully the only justified energized work we're doing is verifying absence of voltage as part of our lockout tagout. So it is not considered electrically safe. It is not considered under lockout tagout until we have verified absence of voltage as one of the steps. So, and even the permit that we talked about earlier, the energized electrical work permit, where it has exceptions for things like voltage testing, but it's not an exception from doing a risk assessment, a shock and arc flash risk assessment. You still need to do that, and you still need to wear PPE. So it's not an exception from PPE. It's not an exception from your risk assessment. Even for the most common, allowable, and necessary justified energized work, verifying absence of voltage during lockout, tagout. You need PPE. You need to do a shock and arc flash risk assessment.
Yeah, and when we consider those additional protective measures, the first thing that we have to consider is creating an electrically safe work condition. And as a safety coordinator for IBEW Local 98, I had the responsibility to investigate every incident. And where there were incidents, I can tell you in every single case, the owner of the facility was there and said, we don't know why they didn't shut it off. We don't know why, because to them, it's just shutting it off. Palmer and I, and you should know that it's much, much more than that. We can't just open a disconnect. But what ends up happening is that the owners, after an incident will say, we don't know why they didn't shut it off. That's why if we run into an owner and the owner says, no, you got to do it energized, you fill out that energized electrical work permit and you give it to them to sign. All right. You make sure that they've got skin in the game. They are responsible for their equipment if something goes wrong. Okay. And the shock and arc flash risk assessment, they have to be done by a qualified person. And that's where we determine if additional protective measures are required. And this is where, and it's the first time in the PowerPoint slide, second time, that we're going to get into the hierarchy of risk control methods. So the hierarchy of risk control methods gets, it's in 110.1H in 2018. It's going to move to 110.5H in 2021. But
yeah, so Jim, let's talk about that. So when did the 2021 edition become effective? And the answer was
that's our key
in June of 2020. So, and in the front of 70E, it says it supersedes all previous editions. So if you are one that says we're going to follow the most current edition of 70E, there's a chance you might already be out of compliance without even knowing it. Matter of fact, the standard became effective before it was even available. Matter of fact, if you went probably through September and looked on NFPA's website for the current edition, it said the 2018 edition was the current edition, even though the standard, and I'm going to look in the front, it was June the 16th, I believe, of 2020. So just be aware of that. June 21st, 2020 is when it became effective. The 2021 edition became effective, and it supersedes all previous editions.
So that's, every contractor that has, and you have to have it, it's a requirement, a written electrical safety program. You have to review that program every 3 years, and you should be reviewing it right now. And if your program says that, Dollard Electric always follows the most recent edition of NFPA 70E, you need to change that. You need to change that to give yourself time to get copies of the document, adjust your policies, adjust your procedures, do additional training. So Palmer and I have discussed this many times. We tried to change the standard, they wouldn't do it. But you may want to put language in your written plan that says you're going to follow the latest edition of the standard in May of that year. So you're giving yourself a window of time to get it done.
And there's really no reason why you can't. Jim is absolutely right. So the committee, the NFPA 70E committee, voted and agreed to a 6-month implementation, and the NEC and the Carlin committee agreed to the same. But NFPA Standards Council said, nope, 20-day phase-in date is fine. It's a voluntary standard. You can adopt it whenever you want. So when you look at the front of the book where it says this supersedes all previous editions, just know that Jim mentioned the one entity, the Department of Energy, that has enforced 70E only recently. When I say recently, probably about a year ago, they went from the 2004 edition to the 2015 edition, and they're currently on the 2015 edition. What makes that interesting, the 2018 edition had been out for quite a while when they went from the 2004 to the 2015 edition. So you can at least they did. They decided they didn't want to go to the latest. They went to the one that made the most sense to them. And I guess we'd have to ask them for that why that reason is. But that's how I guess we can say that, yeah, NFPA Standards Council is correct. It's a voluntary standard, whatever you adopt. So, but this is an important concept, Jim, these 6 steps. We used to be thrilled when we could get people to go from, yeah, I got to work energized to I'm going to wear PPE, but we can see that's the least effective PPE. So,
this is where the qualified person, that journeyman wireman working for you doing a shock risk assessment or an arc flash risk assessment, this is where they're training. This is where the standard tells them to go when they make a determination that additional protective measures are required. The first thing they need to consider is elimination. The last thing is PPE. But NFPA 70E is full of informational material in the annex. There's a lot of good stuff. So there is an Annex F on risk control methods, and they give us some examples here of what we can do, what elimination means, what substitution and engineering controls, awareness, administrative controls, PPE, what that means. But the one thing that we need to keep in mind is that in many cases, more and more today, we don't just implement one of these risk control methods. For example, I may need PPE because I have to get into this equipment, but it may be a panel board that is protected at 1200 amps, and I can, through engineering controls, I can engage an energy reduction maintenance switch. Awareness is going to be there because we have signs. 5 is going to be there because, administrative controls, because we do have procedures and job planning tools. Palmer, anything on those methods?
Now, this is really good examples, because people, when they look at that requirement, they're like, well, what the heck do they mean by, substitution? Well, that's a good example there. And that's what a lot of our JTCs are now doing in their motor control center labs. They're getting it down below the 50 volt threshold where they don't need to wear shock protection. But even more of them are getting the apprentices to wear shock protection in the motor control center lab at the JTC. So they get used to wearing it, because what's the number one complaint? Oh, I can't do the task wearing these voltage rated gloves. Well, maybe they're wearing class 2 gloves instead of class 00 gloves or class 0 gloves, so they're probably wearing the wrong class of gloves. So these are great examples. And again, as Jim mentioned, this is part of what a qualified person has to be able to do to be considered a qualified person. That's the training that they're required now. In the 110.6, I think the training requirements have moved to from 110.2.
Absolutely.
So,
if Palmer and I were working together and the task was to open a low voltage power circuit breaker and then rack it out and then go to a downstream switchboard and verify de-energization, what are we doing? We're creating an electrically safe work condition. But Palmer and I would implement engineering controls. We wouldn't put our hand on that low voltage power circuit breaker. We would use a device to remotely open that circuit breaker. And then we would use a device to remotely rack that device out. That's a very high energy area in the distribution system. And if something does go wrong, we don't want an employee standing in front of that equipment. After an incident, any contractor that looks at those kits to get that done, and they're out there, there's plenty of them, to remotely open and then remotely rack and remotely close, they would wish that they invested in one of those kits to get it done. So the first method is elimination. It's the most effective, and it is in line with NECA's standing safety policy. NECA tells us it is the best practice and that we must eliminate whenever achievable, which means getting that owner and convincing that owner, actually training that owner. And when we train that owner, when we explain to them that they could lose their equipment, there could be injury, there could be lawsuits, then they begin to understand that we truly are the best value. But the last method is PPE. Why did we put that last, Palmer?
It's the least protective, just like any other PPE. It could be a respirator. It could fail, could be used improperly. Maybe it's not maintained properly. So it is the least effective, and that's why it's listed last.
It is. And one of the reasons it's the least effective is it's likely to be impacted by human error. We see all the time, guys, they're in that equipment all the time. They've got an arc rated shirt on. It's July, it's 105 degrees. Well, they roll that arc rated shirt up. We actually saw pictures of this that OSHA had, and he's got his voltage rated gloves on and leather protectors. He gets involved in a flash and very serious burns on both forearms, very serious burns. All right. And to recap, only qualified persons can work on equipment that is not in an electrically safe work condition. Palmer, on the PPE?
Yeah, so when we do get to the sixth of the six hierarchy risk control methods, there's two different things to consider. Personal protective equipment, and we have some examples here: rubber insulating gloves, leather protectors, arc-rated garments, arc-rated face shields, and then we have other protective equipment. So PPE, we all know, it's in 130.7C Charlie, and then other protective equipment is in 130.7D Delta, such as insulated tools, have to have been provided by the employer based on the hazard assessment.
And test equipment. It's easy for us to make mistakes here. We have to train everyone that is going to use test equipment on a job, and 70E uses that term, test equipment. And why don't we just say voltage tester? Because it has to include an amp probe. It has to include a phase rotation meter. There's so many different things that we use, but the employer has to document that the qualified person has been trained on the use of that test instrument. So if everybody's got their own test instrument, I don't know how we're going to get that done. But a very key piece there, Palmer, is the limitations of the test instrument, right?
Yeah, so when we talk about the limitations of the test equipment, we hopefully think about voltage for sure. How many times have we seen someone stick a 600 volt or 1,000 volt tester on a 5 kV branch circuit? They're working on a chiller or a neon light transformer. So certainly that. But category rating is probably the next frontier. Hopefully everyone's been aware of that. Category rated meters. Jim mentioned when he got into the apprenticeship, got his letter that you have to have a voltage tester. We probably got in about the same time, the late 70s, early 80s. And, I was very proud to have my VoltCon meter that was handed down from my great-great-grandfather. It still works. Matter of fact, I have it out in my tool bag at my garage, and, it's reliable. It works forever. But certainly they make those types of meters today that are category rated. But certainly the one that I got when I was an apprentice does not have a category rating. And so that's what we got to look for. So category 4 meters at service equipment, category 3 a little bit further down. But if it doesn't have a category rating, it's sort of like, if you don't know when it's been maintained, is it been maintained? The answer is no. So, and that's another thing that has to be documented proficiency when the person uses it, to show that they know how to use the test equipment, and that, and including its limitations and including the display. So back to Jim's point, are you a qualified person for verifying absence of voltage on a 5 kV branch circuit? Let's say there's a chiller and you have to shut it off. How do you verify absence of voltage? Well, if you're getting your 600 volt tester out, you are not qualified. You better be getting a hot stick out and putting a proximity meter on the end of it. So just things like that.
Yeah, and Palmer's right. We hear about that, unfortunately, with regularity. Somebody taking a 600 volt test instrument and putting it across 4160. And I investigated an incident where just that occurred. And Palmer called that piece of equipment right out. It was a 5 kV chiller. And the individuals doing that work was 2 journeyman wiremen. They were not qualified. They were to enter a conduit into a cabinet. And when they opened it up, they saw some terminals in there, and they looked at each other and they said, no way, that's 4160 because they're too close together, but it might be 480. So let's test it. And when you put a 600 volt tester across 4160, it goes boom. And fortunately, we didn't have a serious injury. But what does that tell you? As soon as somebody cannot determine the nominal voltage, they are not qualified.
And Jim, just go back, that last bullet point there, the first two really covered, but this last point, I think we like to leave you with this message. This is where OSHA tells you that if it's de-energized, that it's energized. So here's more of the full story. I like to boil it down to just easy to remember. If it's de-energized, OSHA says it's still energized. If it's de-energized, it's still energized. So this is a little bit more of the sentence. Conductors and parts of electrical equipment that are de-energized but have not been locked out and tagged out must be treated as energized parts. So while we know what you mean when you say we only work de-energized, just please, we got to tighten that language up a little bit more. De-energization, as you go through your lockout tag out requirements, and when you go through your achieving electrically safe work condition requirements, it is one step. It is not the same as electrically safe or locked out and tagged out.
Yeah, Palmer, and that's a good point. I'm glad you had me go back, because even today we see the lack of lockout tag out. We see devices opened, and in many cases they put a piece of tape across it. And when I would walk through a job and see a guy working in a panel board terminating branch circuit conductors, I saw a feeder landed into it, I would ask them, is this in an electrically safe work condition? And in every case they would say yes. And then I would say, well, then you won't mind grabbing the bus. And I can tell you, nobody ever grabbed the bus. But what did they understand at that point? What they understood was they didn't know. So we were just trying to hammer home a point. I would not have let them grab the bus, but nobody even made a move.
Was that tape out, tag out? I guess it's only
Tape
tag
out,
out if they
tag out.
wrote
That's
on
what
it.
I called it in Philadelphia. But the key is that we have to always strive to eliminate, all right? That we have to strive, just as the NECA standing policy says, all right, eliminate that hazard and create an electrically safe work condition. We have to train wiremen. We have to train apprentices and everybody that the use of PPE is the last in the hierarchy of risk control. We don't want to go there first. And we probably should have mentioned this earlier, but at any point, if you have a question, you can certainly use your chat box, and the moderator will step into the room and tell us that we do have its question. And this is something that I hear Palmer say all the time. You have to use all of NFPA 70E. You can't just go in and get a piece of it, right, Palmer?
We're going to cover that really well on the next slide in the second bullet point. I think this is one of the things that really drives me crazy. So if we had to pick a theme for 70E 2021, it's reorganization. A lot of stuff has moved to a different location. So an article you probably never went to was Article 105, but it had a really important piece of information. So important now it's the first thing you see in Article 110. Hazard elimination, as NECA standing policy says, and as we have hopefully reinforced several times, is the first priority. Now here's one. You're going to say, where the heck did this information go? The next bullet point. When you go into Article 120, achieving electrically safe work condition, and it drives Jim and I crazy when people go into 120.5 and they see these 8 steps, and you'll see books published and you'll see magazine articles published, and they'll say, you have verified and achieved an electrically safe work condition when you've done these 8 things. And you may have seen it, and that's not true. And that seems to be true when you look at 120.5, because it says you have both achieved and verified an electrically safe work condition when you've done these 8 things. But it's bad enough that this used to be in Article 120. It used to be in 120.2a, as you can see there in the last bullet point. So when you're into 120.5, you have to know that 120.2a existed, which says you need to follow all of Article 120 before you can consider it verified and achieved by 120.5. Now, to make things even worse, it's not even in the same article anymore. It's moved to Article 110. So from a purist standpoint, it is a general requirement. So we've moved it to Article 110, but now it's even more far removed. So not only don't you have to, not only is it not in 120.5, it's not even in Article 120 anymore, but this is an important consideration. Electrical conductors and circuit parts shall not be considered to be an electrically safe work condition until all of the requirements of Article 120 have been met. So that means, contrary to what you see when you go into 120.5, and I'll leave that to you to read on your own time, it looks like, it is what it says. You've achieved and verified electrically safe work condition when you've done these 8 things. But remember 110.2 in the 2021 edition, remember 120.2a in the 2018 edition. You've got 4 pages of stuff to do in addition to those 8 steps.
Absolutely. Thank you, Palmer.
Mm-hmm.
All right. And again, big theme here in 2021 is reorganization. And in 2018, we made you wait until you got into Article 130.2 to tell you that the general requirement is to put all energized conductors and circuit parts into an electrically safe work condition before an employee performs work. All right. That's being moved up now. It's moved up front into 110.2. And when we go back here, 110.1 is the priority. Hazard elimination shall be the first priority. That was a NECA proposal, and it's NECA that put that, and now it's up front in Article 110. And the second section is now going to tell you that the general rule is to put things in an electrically safe work condition before we perform work.
In this next slide, you're going to see a lot of things got relocated. So just pay attention. They didn't go away. They just went somewhere else. So Jim, if you just click through there.
Yeah, they're general requirements, and the thresholds that were in 130.2, now they're up front in 110.2. They're there. It's right up front, and they're all in first level subdivisions now, right, Bob?
That was a much needed change. I mean, Jim, to your point, the first decision you need to make, which one of these 4 allows me to work energized, needs to come early in the document, not late in the document. So great change to the standard.
Yeah, and normal operating condition, we're going to run into that. I mean, so the men and women working for us in the field, they need to understand that. In feasibility, that is going to happen. Equipment less than 50 volts, well, we're going to have to take a look at the capacity. And when we say equipment less than 50 volts, what we're talking about is capacity. You have to consider the capacity, because the standard doesn't apply, for example, at 48 volts. But if we had a 12 volt car battery, everybody that's listening has made a mistake with a 12 volt car battery, and you didn't set your clothes on fire and you didn't get 3rd degree burns. You were just more careful and you went right back at it. But if we took 4 of those and put them in series, we got 48 volts. And if we take 100 sets of those, we put them in parallel, we still have 48 volts, but nobody will put a wrench across that, because we understand capacity. And that's what that justification threshold is talking about. So we moved the electrical safety program from 110.1 to 110.5, but the committee wasn't reducing the emphasis on the program, were they, Palmer?
No, and this is, we had to make room for stuff that come first, and what we won't say one's more important or less important than the other, but the priority was to establish electrically safe work condition. So yeah, the electrical safety program, and I'll tell you, if you're looking for a place to dig in and maybe where you can do better, get into 110.5. It used to be 110.1, so we've relocated it. We've added some new requirements there as well, but it is a big, comprehensive subdivision in the standard 110.5. And then another relocation is the next bullet point, the training requirements. So it used to be, you go into Article 110, the first thing you see is electrical safety program. The next thing you see is the training requirements. It moved from 110.2 to 110.6. And then the training requirements for test instruments are relocated from 110.4 to 110.8. That's where it says only qualified people can use test equipment. So 110.6 is another place where I'd spend time. This is where it tells you that your employees have to demonstrate proficiency and have it on file for the duration of their employment for them to be considered a qualified person.
Yeah, and Palmer and I, we have done 70E training for journeyman wiremen, and the contractors are in the room, and we have to tell them, look, when we're done with this training, you're not done, because we're not training you on the test instrument that you're going to use. So the employer, that's you have to identify what test instruments they're going to use. So if the test instruments are only for measuring voltage, then the easiest thing to do is buy one type of test instrument. If it's only being used to verify the absence of voltage, it could be a solenoid type test instrument that's a voltage detector, and you train everybody on the same one, and you got it done. We also tell contractors and everybody in the room that somebody needs to be trained in first aid procedures and CPR. Okay, that's the employee that is going to be responsible for responding in a medical emergency, right, Palmer?
That's correct.
All right, and human error is still a focus in 2021, but there's one change here that Palmer and I, wanted to focus on with respect to human error is, and we provided some clarity for you, the employer, with respect to human error. We added some words in 110.5 H2 that tell you that you have to address the potential for human error relative to electrical hazards in the workplace. And we look at incidents, and in almost all cases, in every incident that occurs, there is, to some degree, somewhere in that chain, human error. Unfortunately, our instinct is to automatically go to the man or the woman that was performing the task that got injured or created that fault and say they made a mistake. In many cases, there's human error that occurs upstream as well, because that individual should have never been put into that position. Maybe they weren't qualified. Maybe the work wasn't justified. Maybe the PPE wasn't adequate, and somebody upstream knew that. And in NFPA 70E, as we mentioned earlier, Palmer and I referred to Table F3 and Annex F for risk control. There's a whole Annex Q, on human error, and it provides significant insight in how to address the potential for human error. And it points out many things too that I always like to touch on, and that is that we are all fallible. Even the best people make mistakes. Everybody makes a mistake. And the second is that error likely situations and conditions are predictable. They're not just predictable, they're manageable and preventable. Palmer?
Yeah, Jen, I would suggest that, and folks that really are looking to move the needle again would spend some time in Annex Q, informative Annex Q. It's not mandatory, but great information. So here is an example. Most people think, oh, it's just a person that was at the end of the circuit there doing the work. So it's important to recognize all aspects of this. So here's what Annex Q says. Human performance is an aspect of risk management that addresses organizational, leader, and individual performance as factors that either lead to or prevent errors and their events. So there's three different components there: organizational, leader, and individual performance. So that's how Annex Q at least introduces the topic. It is more than just, the individual. Maybe why did that human performance issue arise? Was it because of lack of training? Was it because of that they weren't qualified? Was it because of, fill in the blank? So that's really, it's a big picture. And I think it's an interesting topic that many of you are already probably involved in, but I would invite you to get into informative Annex Q as well.
Yeah, Palmer, that's absolutely right. I think it's one of the best reads. If you're charged with safety in your company and you're charged with electrical safety, then you have to own Annex Q. And one of the most interesting things in there that was a takeaway from me is that people do better when you recognize them, when you give them an attaboy for doing things right. Far too often when it comes to safety, we want to go on a job and we just want to point out what's wrong. But when we go on a job and they're doing 95% of things right, we have to give them attaboys and say, hey, this looks good, that looks great, you guys got this covered, but there's some areas that we need to tighten up, and let's tighten up here. That goes a long, long way. It can't work from the top down only, and it can't work from the bottom up only. Okay. It's a shared responsibility. Safety is a shared responsibility. We have to work together, and we have to recognize when people are doing the right thing. NECA submitted multiple public inputs last cycle to address high visibility apparel, and they were accepted. And Palmer, you want to discuss outer layers?
Yeah, so that is a great question. So high vis has become a big deal, and the standard didn't specifically address that high vis had to be arc rated, and it does now. So any outer layer that we wear when we need to wear arc rated garments has to be arc rated. So the high vis was a new addition here. What also you might not think about is hooded sweatshirts or winter coats or rainwear. It seems like really they make arc rated rainwear, and yes, they do. So that high vis was added to that list for the 2021 edition. The other thing that you see there on this underlying text that was added, some questions. So this was clarification. So does my high vis vest, let's say I have to wear 12 calories that's what the hazard assessment shows me, that I have to wear 12 calories. Does my high vis vest have to be 12 calories? Well, good luck finding a 12 cal high vis vest. Or what about my rainwear? Does it have to be 12 calories? And so this extra language here clarifies that. The arc rating of the outer layers worn over arc rated clothing as protection from the elements or for other safety purposes, and that are not used as part of a layer system, shall not be required to be equal to or greater than the estimated incident energy exposure. So that's the explanation, that your high vis, if you're required to wear 12 calories of protection, your high vis vest doesn't have to be 12 calories or any other outer layer, unless it's part of a layered system. So that's generally how arc flash suits get there. It's not a single layer garment, it's multi-layers that get you to that 40 calories.
Yeah, thank you, Palmer. And one of the things that we saw was people using flammable high vis apparel. That's a really big problem. And we need to keep in mind that we strive for perfection when it comes to the arc flash hazard. We're never going to get it perfect. The key is to get people out of flammable clothing. People aren't getting killed and seriously injured because they weren't wearing the right level of arc rated clothing. They're getting killed and injured because they're not wearing arc rated clothing. They're wearing flammable clothing. We get clothing ignition and it's game over. So stop just for a second and think to yourself, am I wearing arc rated clothing right now? I can tell you that I'm not wearing arc rated clothing. So if you're not wearing arc rated clothing and somebody asks you what you're wearing, and we're talking about 70E, the answer is fuel. You're wearing fuel, and nobody wants to wear fuel to a fire, right, Palmer?
Yeah, I know some people that I would like to.
Oh, God. Okay, all right, this change, and you see it in 130.7, that's the general requirement for outer layers, but we refer to it in table 130.5G, which is a table for PPE if you're doing the incident energy analysis. And we also refer to it in the arc flash PPE tables as well. And Palmer, there's a new table, the committee pushed back for multiple cycles. They didn't want to add a table that got us into maximum use voltages, et cetera, for gloves. Can you discuss how the committee came
Yeah.
to accepting this table and why it looks like it does?
Well, this is a great table so obviously the left-hand column has the class of gloves, and so certainly the second and third column was already in OSHA. So in 1910, 137 in subpart I for general industry, and in 1926.97 for the construction standard, this has been in there, but it was certainly conspicuously absent from 70E. So now you can see what's the maximum use for a class 00 glove. It's 500 volts. So great information. Now, the thing that might not be as obvious, and the next column over would be for DC. The far right is what most people don't know is, well, there have to be a distance between my rubber insulating glove and my leather protector, because the leather protector obviously is not insulated and the rubber insulating glove is. So you got to have a gap there. So that's what they're showing you for class 00. You need at least a ½ inch gap between the insulation and the conductive material. And then all the way up through class 4, you need 4 inches. So they call it moat around the castle. You need that separation. And the other thing is, you don't want to see too much exposed either at the same time. So this is a great tool. It came from the ASTM standard for these gloves to give you an idea. So, sometimes you'll see people with a glove with, 12 inches of exposed rubber. That it's easy to get punctured. So the rubber insulating glove is the insulation. The leather protector is a protector. It's going to protect against punctures and things of that nature. So great addition to the standard.
Absolutely. And keep in mind, in the 2018 edition of the standard, we revised the table note, which is enforceable to table 130.7C7. And it reads, new insulating equipment is not permitted to be placed into service unless it has been electrically tested within the previous 12 months. And that didn't change. But this new sentence now clarifies that insulating equipment that has been issued for service is not new and is required to be retested in accordance with the intervals in this table. So that means 6 months. So when I got a brand new pair of gloves, Palmer, and I send them out and I get them tested, when they come back, I only have what? 6 months.
They're only new once. That's the moral of the story.
Yeah, because they are no longer considered as a new glove. Okay, there was a significant change to the definition of electrically safe work condition. And this change is in the informational note, which we're going to throw on the screen here. But we had people in the industry saying that an electrically safe work condition didn't constitute elimination. They were saying that there's no way that you can eliminate an electrical hazard, and that's incorrect, and it was misleading. So there's a new informational note, and here's how it reads. An electrically safe work condition is not a procedure. It is a state wherein all hazardous electrical conductors or circuit parts to which a worker might be exposed are maintained in a de-energized state for the purpose of temporarily eliminating electrical hazards for the period of time for which the state is maintained. That provides a lot of equipment. And, that first sentence there is extremely important. An electrically safe work condition isn't a procedure. It's a state. It's a condition that we create, and we have to create it properly. If we just open a disconnect, well, all you know is you move the handle. To Palmer's point, when we create an electrically safe work condition, we've got a whole lot more to do. Palmer?
Yep, that's pretty much stands on its own. So this is a good parallel to some of the other discussions that we have. So when you look at the definition of qualified person, you see a definition. And here, when we see electrically safe work condition, we see a definition. There's 4 components here. A state in which they have been disconnected. That's what I say most people are calling de-energized. Then we've locked and tagged it in accordance with established standards. Then we've tested to verify absence of voltage. And then we've applied temporary protective grounding for personnel protection. So there's 4 components to this. But when you get into Article 120, you can see that Article 120 is a lot more than just a definition. Just like when we go to definition of qualified person, yeah, we see a definition. It gives you a high level overview, but until you get into the training that needs to be documented, that's how you get the full picture. So I'm going to tell you, Article 120 gives you the full picture of the definition of electrically safe work condition, and 110.6 gives you a fuller picture of what the training you need to have to be considered a qualified person. So great informational note there to clarify what exactly electrically safe work condition is. It does equal elimination.
All right, so we're gonna end the presentation with multiple slides that get us into shock and arc flash risk assessments, and this is all part of the NECA guide to shock and arc flash risk assessments. And NECA is presently working on an app, so the app is going to look a whole lot like the guide, but it will be an app, and you'll be able to take your phone. I could be a qualified person, and I can walk through a shock and arc flash risk assessment. It's going to be almost like the Energized Electrical Work Permit app, and they're all on the Toolbox app that NECA has out there. So that's coming, and I think it's going to be a tremendously productive tool for everybody, because as Palmer and I pointed out, you have to document every shock risk assessment, every arc flash risk assessment, and that app is going to give you the tool to do that. So it's all about training, and the training has to include practical application to perform these risk assessments, but it can't stop there, all right? And Palmer beats this home all the time. We have to demonstrate proficiency in the performance of those risk assessments, right, Palmer?
Yep. So I think step one is I got to flip my phone open, right? The phone has to flip open.
Phone open because you still have a flip phone. That's correct. That is correct. And, let's take a look at some of the defined terms. And, in 2018, we defined hazard as a source of possible injury or damage to health. And some people say, why did you do that? Did you really have to do that? We did, because we had owners telling us that de-energizing their data system created a hazard. Well, it was an inconvenience, but it certainly wasn't a hazard. And an electrical hazard is defined as that contact or equipment failure can result in shock, arc flash burn, thermal burn, or arc blast injury. And the electrical safety program is going to drive, in 110.1H, now it's moving to 110.5, the hierarchy of risk control. But up front there, before you get to the hierarchy, this is what electrical contractors have to do. They have to provide elements of a risk assessment that employees have to take before the work starts to ensure that they identify electrical hazards, assess the associated risks, and implement risk control according to the hierarchy of risk control methods.
Jim, that illustration is really interesting. I can't tell you how many people have told me, you need to flip that thing over because it's wrong. But when you really look at it, the foundation at the bottom, the base is the elimination. People say, well, why is that not first? Well, it is first. So we build them from the ground up.
That's right. All right. And then human error has to be considered in a risk assessment procedure, because there's always that potential, and it can have negative consequences on people's processes, the environment, and on equipment. And remember, we took a quick look at that. Okay, those error likely situations are predictable, they're manageable, and they are preventable. We just have to take a look at them. And we talked about this earlier. Everybody makes mistakes. None of us are infallible. And all of that performance is influenced by processes and values in your organization. And safety can never be a priority, because priorities change. If we're running late for work, we forget that cup of coffee. We don't get breakfast. We are out the door. All of those priorities that we normally have get thrown out. Safety is a core value. It can never be compromised. And this was the other piece that I had mentioned there, Palmer, and that is that, the men and women in the field, if we give them encouragement and reinforcement, they reach high levels of performance when it comes to safety.
And you got to have buy-in. You'll see, everyone probably listening to this knows that already. You need buy-in from the people that are going to have to put it into practice.
Absolutely. And, when we understand why those mistakes occur, and when we share that with the men and women in the field, we can collectively learn from the past. We can learn from those past incidents. And, we keep calling them incidents because they're not accidents. An accident is an unforeseeable occurrence with an undesirable outcome. So I'll give you an example of an accident. You're driving somebody home this time of year. The deer are very active. It's dark. You're in a neighborhood that you're really not familiar with. You drop them off. You start driving away. A deer jumps out. You swerve and you hit a car. That's an accident. It was unforeseeable and the outcome was undesirable. But when men and women that are journeyman wiremen go into energized electrical equipment, okay, it's not unforeseeable. They know those hazards exist. And when something happens, it's not an accident, it's an incident. Okay, we went through the hierarchy of risk control already, and this notes it. It's in 2021 as 110.5H3. Okay, it's going to include the risk control methods that have to be implemented. There's 6 methods. We went through those, but the key is that last sentence there. In many cases, we're applying more than one of those methods in the hierarchy of risk control. And Palmer and I, we took a look at that, but this is very similar to what you see in Table F3 and Annex F, but it's just in a little different format in a PowerPoint slide. All right, these are some really important definitions here when we get into risk and risk assessment. But, we all think about risk because we're always looking at the stock market, and you say, what kind of risk can I tolerate? Well, when we get into 70E, risk has nothing to do with the stock market. It's a combination of the likelihood of occurrence of injury or damage to health and the severity of injury or damage to health that results from a hazard. So what is likelihood? Okay, likelihood is the potential of something happening. So everybody that is on the web right now, listening to Palmer and I, you've gotten in a plane and you went on vacation, you took a flight, you went somewhere. Is it possible that the plane goes down? It is. But now you have to ask yourself a question. Is it likely? The answer is no. So you know what? Once this COVID-19 clears up, go on that vacation because there's not a likelihood that it's going to go down. But a risk assessment, this is where we put it all together right here. And this has to be a focal point for everybody that is online right now, because this doesn't just apply to electrical hazards. It applies to all hazards. A risk assessment isn't a single step. It's a process. It's an overall process that first identifies hazards, second, estimates the likelihood of occurrence of injury or damage to health, third, estimates the potential of severity of injury or damage to health, and determines if protective measures are required. So we do risk assessments all day, every day, and we don't realize it. You're driving in the car, you're doing 60 miles an hour and your phone dings. And what a lot of people, they grab that phone, they reach for that phone and they're looking at it. Now that's distracted driving. They know that. So they have identified a hazard. They're sitting there pressing buttons, but they get to the next step and they do it subconsciously and they do it instantly based upon their experience. And they estimate the likelihood of an accident. They estimate the likelihood of injury or damage to health as nil. It's negligible. And what do they base that upon? They base that upon their experience because they do that all the time. And Palmer, I know you never do that, right?
Not anymore because I don't drive anywhere anymore.
Okay, Likelihood is a condition that something is likely to occur. And 70E gives us a table. It's table 130.5C, and it gives us tasks. And it says, hey, these are likely to create an arc flash exposure, and these aren't. But keep in mind, likelihood is just one piece of the risk assessment. We have to take in the potential severity into account. It's just one piece. We're not getting in to the severity. Exposure in an industrial control panel to a 277 volt circuit is completely different than exposure racking in a 2000 amp low voltage power circuit breaker into service equipment. We have to take the potential severity of the arcing incident into account. 70E doesn't come with an easy button. It would be really nice if it did. We could just hit that button and say, what do I do in this situation? And severity is based upon the hazard. It can range from minor to catastrophic. And the risk assessment has to consider likelihood of occurrence and that potential severity. And we're getting pretty close here. We're down to about 9 minutes. So there's a normal operating condition. I'm going to skip through this one because we went through that. The boundaries, okay, they trigger requirements. You got a limited approach boundary, restricted approach, and arc flash boundaries. There's two types of risk assessments: shock risk assessments in 130.4, arc flash in 130.5. And in any shock risk assessment, what's step one? Identify any shock hazards. 2, estimate the likelihood of occurrence of injury or damage to health and the potential severity. 3, determine if additional protective measures are needed. And if they are needed, we know we got to go back to the hierarchy of risk control. And number 1 is eliminate. That always has to be the first thing that we consider. But when we're doing those risk assessments, we look at the design of the equipment. We also look at the operating condition and the condition of maintenance. And additional protective measures would include the voltage that we're going to be exposed to, the boundary requirements, and any required personal protection.
Let me make a quick point here if you back up. So everything Jim's talked about to this point is shock risk assessment, and we want to estimate the likelihood of it occurring. Well, we do have a table 130.5C, estimate the likelihood of arc flash occurrence, but we cannot use that table for doing our shock risk assessment. So that might be potentially confusing to you. Table 130.5C, Jim's going to get into it next. Estimate of likelihood of occurrence of an arc flash incident. You cannot use it for shock.
Absolutely, Palmer. Thank you. And then when we get into an arc flash risk assessment, 70E tells you, identify arc flash hazards. If we don't have an arc flash hazard, then we don't need to do anything else. And again, step 2, estimate the likelihood of an arc flash incident occurring and injury or damage to health and the potential severity of injury or damage to health. That's going to be specific to that task and that equipment. 3rd, determine if additional protective measures are needed. This is where we go back to the hierarchy of risk control. There's more here when we start to take a look at what we need to consider. We got to look at the design of the electrical equipment. We have to look at that upstream overcurrent protective device. We have to make sure that the men and the women in the field understand and know the difference between a standard molded case circuit breaker, an inverse time type device, a molded case circuit breaker with an adjustable instantaneous, an electronic trip molded case circuit breaker, an insulated case circuit breaker, and a low voltage power circuit breaker. We have to make sure that they understand the typical clearing times for those devices, which ones have an instantaneous override, which ones don't, and the maintenance requirements for those, and how to determine operating condition. And additional protective measures would include appropriate safety-related work practices, and they will be the employer's work practices, the arc flash boundary, and any required personal and protective equipment. Now, Palmer mentioned the estimate of likelihood table of an arc flash occurrence, And that's table 130.5C. And here's just a little piece of it. Here's just a little piece of it. And I like to take a look at that second one down. It says performing infrared thermography and other non-contact inspections outside the restricted approach boundary. And we're going to tell you on the right that that's any equipment condition. There is no likelihood of occurrence. But look at the last part of it. This activity does not include opening of doors or covers. Because when we open a bolted cover, Palmer, we have an arc flash, a likelihood, right?
Absolutely.
Okay. And shock protection boundaries have to be considered when we're, the limited approach boundary, restricted approach boundary, and limited approach boundary. This is where something can occur. All right. That's what we're saying, that a hazard exists. So from 50 to 750 volts, it's going to be 3'6". And you're going to go into table 130.4 DA and DB. Restricted approach, now we've got an elevated likelihood because now we're closer. There's an increased likelihood due to arc over combined with inadvertent movement. And again in 130.4, the arc flash boundary applies only when an arc flash hazard exists. If I've got a panel board, nobody's working on it, it's all buttoned up, I don't have an arc flash hazard. By definition, the arc flash boundary is 1.2 calories, and it's determined through an incident energy analysis or by the PPE table. Palmer and I went over the requirements for shock risk assessment, and I'm not going to go through everything here because we are running out of time, but this really lays out, and it's part of the guide, the shock and arc flash risk assessment guide. It lays out for that trained person, for the qualified person. It helps walk them through the shock risk assessment process. So step one, identify shock hazards. And this is what they need to do: determine voltages, identify exposed conductors and circuit parts, consider unexpected events, estimate likelihood. Are we going to cross the limited approach boundary, the restricted approach boundary? Let's take a look at every task that we're going to perform. Then estimate the potential severity, which would include the design of the equipment, the operating condition of the equipment, and the condition of maintenance.
And Jim, step 4 there is really the essence of this. Okay. You've identified a shock hazard. Now we're going to say, do we need additional protective measures? What most people would do is say, I'm getting shock protection, I'm doing the work. But this is where we have to say time out, go through those 6 steps, try to eliminate, try to substitute, and then if we get the PPE, we get the PPE.
Absolutely. We're down to just over 2 minutes, and
Jim?
that's the additional protective measures, and we'll be able to get through these couple, and then that's the end. And when PPE is required, all right, we have to determine the voltage, the boundaries, and the PPE is needed. And is a second person required? 70E is not going to tell you when it is, okay? That's going to be your call. You make that determination on a second person. Very similarly,
Jim.
arc flash risk assessment process, are there exposed conductors or circuit parts? If there are, I've got an arc flash hazard. Are we going to interact with the equipment in a manner that increases the likelihood? If that's true, then I have an arc flash hazard. Then I estimate the likelihood. I got to take a look at the tasks. If I have exposed conductors or circuit parts, if we're going to interact, and we can use the table 130.5C to determine the likelihood. Are we going to cross the arc flash boundary? Then we, okay, go ahead. Yep, because.
Okay, Jim.
Go ahead.
Is new insulated equipment considered sealed equipment? And does that mean longer than 12 months after manufacture date and still seal require testing?
If it's new, if it's brand new, okay, if it's brand new and you've got a test date on it, right? So I got brand new gloves and it's got a test date on it. I can issue those gloves up to 12 months of that test date. But if I go over 12 months from that test date, even though they're still brand new gloves, I have to send them out and get them retested. Palmer?
Okay. And one other question, and it's almost rhetorical, but when will all locals require that all the electrical workers be qualified and that these workers have to attend CEU classes like almost every other profession has to?
Yeah, well, we tried to float a resolution at the most recent convention to get that done. It was unsuccessful. So I would urge every IBEW member to try to pursue that with your own local, within your district, and approach all the vice presidents and say, hey, this is something that we need to mandate within the IBEW. Linemen get that training.
We got
linemen.
Brian on here. This sounds like a labor relations question.
Yes, indeed. Don't want to put them on the spot though. And
Yeah, I'll reserve
Just one-
my comment.
just one other observation is, do you see doing in-person classes on this in the future? People would like to.
I think it's going to take some time. I don't think we're going to, we got to get COVID out of the way. My personal opinion, and everybody's got an opinion. I mean, I think it's likely we got to get into third quarter next year, probably.
Well, if you want to get any kind of reading the tea leaves, the fact that OSHA, who was very reluctant to allow virtual training for OSHA 10 and 30 and OSHA 500 and 510 and 502, they have now, they've given us permission to do virtual training through July 31st of 2021. So so that to me, if you're looking for a signal of when OSHA thinks in-person training is likely to occur, then that I was just surprised when I saw them extend us the allowance to do virtual training to July 31st of 2021.
Yeah, I certainly hope that it happens sooner than later. And as you can see, listening to Palmer and I, we enjoy doing this, and we really enjoy the face-to-face classes. I missed them.
Thank you, gentlemen. Our time is just about up, and I want to thank you for a very informative presentation. I learned a lot today too. So,
all right. Well, thanks everybody for attending. We really appreciate you being here.
It's our pleasure. Thanks to NECA for allowing us this time.
Yes.
Welcome to NECA's eSafety line, developed by NECA and Intech. This video is a brief introduction and navigation guide through the program. eSafety line is a compilation of safety resources and tools. Each menu square provides access to an administrative aid, such as written program templates, training materials like safety talks, a record-keeping application, or links to key safety websites. Some menus are basic. The OSHA and CDC menus are links to their websites. Others, such as Safety Talks, NECA Archive, Access Records, and Access Programs, are extensive. For example, the Safety Talks section offers 4 new talks each month, with an archive of more than 300 talks. The NECA Archive contains a library of NECA publications that are available in digital format, including the 70E series, Silica and Aerial Lift Guides. A searchable database is provided to access the volumes of digital content developed by NECA and Intech over the past 30 years. Access Records is an application to keep safety records, including OSHA injury and illness data. Access Programs is a menu to download programs that are OSHA compliant and meet third-party evaluator requirements. Additional menus offer webinars, a safety calendar, and listserv features. But more importantly, the program is a living document. It is constantly updated. Frequent visits to the site are recommended as menus and content change. A recent update was the addition of a COVID-19 resource module. Proposed changes for the coming year include enhanced alerts, with optional phone app push notifications, a hazard awareness training menu with additional modules for PPE, fall protection, and more, and a new special feature, the Serious Injury and Fatality Prevention Coach. For more information, contact NECA or Intech. To order a subscription to eSafety Line, call or visit the NECA store.